in this first video for this set of notes, we're mostly going to talk about giving you kind of an introduction to slopes and the definition of what is calculus, and we're going to connect calculus to slopes by using things such as like rates of change and speed and velocity, where a slope in algebra meant, well, what is the rise, what is the fall of a line? And in calculus, it's not only the rise and fall of a line, it's that slope represents the speed of an object, the velocity of an object, which is the rate of change. So anyway, we're going to connect all of those things together, and hopefully in this set of notes, we're going to connect algebra to calculus through what you know as slopes. So first of all, looking at the average rates of change, that is by definition what a slope is. It's just an average rate of change. Now remember, average rate of change is the amount of change divided by the time it takes. Okay, remember the distance is equal to rate times time. Well, the amount of change is represented by a rate. So solve this equation for rate. You'd get distance over time is equal to rate. So, and remember, rate is a rate of change, which today we're going to connect that to speed, which is the same thing as velocity, except velocity is directional, which is a rate of change, which is a slope. Okay, so to find the speed of an object, you just figure out what the slope is given its velocity graph. Okay, now the average rate of change of a function over a given interval is the amount of change divided by the length of the interval. Okay, so now this is really tricky. On the AP exam, they might throw this in there, they might not. I would guess that they won't on a multiple choice, but it could be on a free response. But average rate of change, no calculus involved. Okay, so in your notes, your homework, tests, quizzes, if I ask you for the average rate of change, there's absolutely no calculus involved, and I'm going to show you. So if we take a look at an example, it says find the average rate of change over each interval. So you have the natural log of x. Alright, so we're going to look at the graph. If you haven't, go ahead and graph the natural log of x. It looks like this. Okay, this is the natural log of x, the red line right here. This is what it looks like. Now what you're going to do is you're going to calculate on average what is the slope of this line. Okay, so you notice if I draw a little line of the slope here, 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 the slopes are getting, you know, the slopes of the lines getting smaller and smaller because it's going up really fast here, but then it starts to level out. But we know natural log of x graphs never actually do level out. So anyway, average rate of change, and this is how it works. So to find the average rate of change, all you're doing is finding the change in y over the change in x. How far up or down, how far left or right. That's it. Basic algebra. Just looks a little different now. Okay, we're going to then transform that to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Again, should look more familiar. So we have then the natural log of 4 minus the natural log of 1 all over 4 minus 1. So you then remember the natural log of 1, if we come back and look at the graph, the natural log of 1 is 0. So you'd have natural log of 4 minus 0. So you just have the natural log of 4 all over 4 minus 1, which is 3. And if you simplify that, put it in the calculator. So on a multiple choice exam, this is an option. The 0.462 would not be an option, but I'm just going to simplify that for you so we can compare numbers here. Okay, so this was the average rate of change from 1 to 4. Okay, so if we come back to the graph, So if I were to draw a tangent line, or no, a secant line, so put a dot at 1 and put a dot at 4. Okay, so put a dot there and put a dot there, and then connect them. So look, here's my natural log. Here's at 1, here's at 4. What I mean by a secant line, remember, is a line that connects those two. If I found the slope of this line from 1 to 4, it's going to be exactly 0.462. Okay, so that's basically what I found by finding the slope of that secant line. That gave me the average rate of change. Alright, let's try the next one. Now, instead of from 1 to 4, we are going all the way out to 100. So here's a graph of the function from 100 to 103. And so you notice that line, unless you look right here, you can notice there's a little bit, it goes up a little bit. But basically, if I were to put a point at 100 and put a point at 103, then connect them, it would basically follow that red line, meaning the slope is what? 0, correct, I heard you all. So anyway, we could check our answer because we know that it should be somewhere around 0. Okay, so we're doing the same thing, but now our y values are different, or the x values are different, therefore our y values are going to be different. So it's going to be the natural log of 100 minus the natural log of 103 all over 100 minus 103. Doesn't matter, I know I switched them around, but as long as I'm consistent here and here, whoops, that's a 3. Erase it. There we go. So that's a 3. As long as I'm consistent here and here, it doesn't matter because I get negatives here, which will be positive anyway. So you'll get natural log of, so basically you get a natural log of 103 over 100, so that's natural log of 1.03. Oops, man. Okay, that's what this ends up being, because you'd have 100 minus 103, so that's 103 divided by 100, or 100 divided by 103, whatever you want to think about it, but then it's going to be all over, if we change them both to positive, it's going to be all over 3, and that will give you 0.0099. Now this is extremely close to 0, which we saw in the graph. That's exactly what it should be. Okay, so that's kind of an introduction into how we're connecting calculus to what you've already known to algebra. But the difference is, like with the natural log, okay, what we've done is we said, okay, we want to find the average rate of change. And so that is the slope of the secant line. And so when you find the slope of the secant line, that's easy. It's the slope between 2 points. However, calculus is a little more complex because now what we're finding is, instead of finding the average between 2 points, I want the exact slope at a point. So let's say I want the slope at this point. Draw what's called a tangent line, which is the line that represents the slope at that point. So that green line is what we call the tangent line. So that's the tricky part, is figuring out how do I find the slope of a line given only one point. And that's where calculus comes into play. Okay, so that's it for this video. I'm going to move on. The next video then is going to be about the definition of finding the slope using calculus.